You ready? Welcome, everybody. Good morning, and thank you for joining our first webinar that we'll be hosting to introduce TangentWorks to the North American market. My name is Philip. I'm responsible for strategy and business development at Bardess, and I'm joined by Daniel, our lead data scientist. On today's call, we'll be talking about creating a forecast, why it's typically quite difficult for you, what your current options are, and then end off with a demonstration of TIM, TangentWorks information modeler. This TIM product removes the complexity and provides you with the best option to create a time series forecast. We'll close with contact information for Daniel and a link to get 2 weeks free trial access to TIM so that you can try it for yourselves. If you have any questions during this webinar, feel free to type them into the chat box and we'll try and get to them at the end. Producing a time series forecast is fundamental to every line manager's job function. Perhaps you're responsible for managing emergency room staffing and you need to decide how many nurses and doctors you're going to need for tonight's 8 p.m. shift. Or perhaps you're a bank and you need to calculate your loan loss reserves. You need to cover defaults for the coming quarter. How about a factory floor manager who needs to maintain high operational efficiencies in utilization of the equipment in your factory floor, and downtime is a big problem. Perhaps being able to have the right part on hand when it fails is very important to you, and that is part of predictive maintenance. We have customers who need inventory level forecasts, transportation capacity forecasts, and call center volume forecasts. All of these use cases have one thing in common. They are time series forecasting problems. TIM is the easiest way to produce a forecast. And a time series forecast is nothing more than a technique to predict events through a sequence of time. And although it's usually difficult and expensive and time consuming, we look forward to showing you some alternatives today. At the same time, producing an accurate forecast is one of the easiest costs that you can tie back to tangible ROI for your business. So we do thank you for being on this call with us today, and we look forward to talking some more about time series forecasting. You know, time series forecasting is something of a dark horse in the field of data science. Although it's one of the most applied data science techniques in business, used extensively in finance and supply chain management and production management and inventory planning, as we discussed. And it has a well-established theoretical grounding in statistics and dynamic systems theory. It yet retains an outsider status compared to some more recent and popular machine learning topics such as regression, classification, and natural language processing. At the crux of this disconnect is that time series forecasting can be cast as a supervised learning problem, and hence the entire arsenal of machine learning methods can be thrown at it. But at the same time series forecasting problems have several unique quirks and idiosyncrasies that set them apart from typical approaches to supervised learning problems. This requires data scientists to rethink their approaches to building and evaluating models. Let's look at an example. Imagine your job as an operations manager is to make sure that you always have enough bikes ready for your customers. They need to be roadworthy and available at the right locations. In a typical bike sharing operation, there are several locations around the city where bikes need to be. Some of your customers have been loyal customers for a while. They signed up and they use your service and they enjoy the benefits of being a loyal customer. Then there are some customers who need a bike in a hurry. Maybe they're late for a meeting across town and Uber might take too long. Or maybe they're family visiting from Europe and they want to tour the city and every family member needs a bike. These are casual customers and you need to make sure that each one of them has a good experience. Total demand for your bikes then is both the registered users plus the demand for your casual users. How do you go about forecasting how many bikes you might need at each location? You may have some historical data and you can see that this demand over time has varied, maybe from day to day, hour to hour even. And if you look carefully, there's a general trend over time. You also look at this data and you can see there's some seasonality. Of course, in the summertime, maybe there's more people renting your bikes than during the winter months. And the question comes, what other factors do you think might influence the demand for bikes in this scenario? What about if there's a thunderstorm? What about the time of day or the humidity? These factors are called features by data scientists. Now, if we build a forecast just from using the actual historical demand, we call that forecast a univariate forecast. So if we take date and time and the demand, and we create a forecast of the demand, we end up with what's called a univariate forecast. If we're able to use more features to create our forecast, like the weather, or whether the day is a weekend or a holiday, or whether it's winter, and we add that to the historical demand, we call that forecast a multivariate forecast. And the benefit of a multivariate forecast is not just getting the demand back, but also getting an explanation back as to what features may have impacted that model and allowed you to understand your data a little bit better. Univariate forecasts are actually quite accessible to the average business user. But what if you want to improve the accuracy? Because I think everyone intuitively knows that if you're able to take the historically trended data and add the other factors or features into it, that you might have a more accurate forecast. And this multivariate forecasting is what we can talk about next. Before we go there, univariate forecasting, again, here's just an example of it in a sample application. And it literally only requires the demand and time to generate the forecast. So if you come to multivariate forecasts, what are your options? You could try building what I'm calling a handcrafted model. Perhaps you use R or Python and other libraries like XGBoost and TensorFlow. And as the name suggests, all the work is coded manually, and you need to be an expert to do this as well. Notice that the model building process itself is recursive or iterative, and it takes several iterations before it can be deployed to be useful. You could also use popular AutoML tools that are available on the market today. These solutions do a great job automating some of the engineering steps, but they still go through all the steps and still require this recursive piece. Finally, we have Instant ML. This is unique to TangentWorks, and this is why I'm so excited about this new solution. Tim takes a completely different approach. Instead of trying to find the right algorithm, which is quite characteristic of the other two methods, Tim determines which features or factors in the data are most important. This is a game changer. Tim can produce a more accurate time series forecast in seconds, is easy to use, and because it then can be integrated into many other tools right inside of Excel or your favorite analytics platform, which we'll show you in a second. We'll be using it in Qlik. It's incredibly accessible to the average business user. An interesting side effect is that when Tim builds a predictive forecast, it's finding which features in your data are predictive. This can be sometimes more important than the actual forecast itself, because if the features change from one forecast to another, then that tells you that something in your business has changed. This is called anomaly detection, and it's provided out of the box by Tim. And one of the things that Daniel is going to demonstrate today is some of the anomaly detection features. So we're going to get into a demo. I know this is what you've all been looking forward to. What I want you to kind of pay attention to as Daniel goes through his forecast, he's going to show you Tim in Excel, how a simple plug-in to Excel can generate a time series forecast. He's then going to up the ante, as it were, and show you integration of Tim with Qlik, where we can actually dynamically add more features and see the forecast changing. We're also going to realize that having a forecast is just is important, but also knowing why you have that forecast is important, and that's what we call explainable AI, to see which features are important. And then finally, Daniel will be finishing up in Tim's studio, which is the Tim web platform, where he'll show you some other features. So without further ado, I'm going to stop sharing. I'm going to hand over to Daniel. Demo.
Okay, great. Thanks, Philip. So I'm just going to start sharing my screen, and we can go through the demo. Okay, so you should see this Excel spreadsheet now. Maybe you could confirm, Philip.
I can see it. Thank you, Daniel.
Excellent. Yeah, so for the demo, so before I start, I just wanted to say, if you have any questions, then there is a chat feature in the Webinar Jam platform. It's in the right-hand menu bar, I think. So if you click on that, then you should be able to send a chat message. So if you have any questions about TangentWorks, then please send in questions, and we'll try and answer those at the end of the webinar.
Yeah, Daniel, that's great.
Yep, for sure. Cool. So this is the data set we're going to look at for the demo. So as Philip was saying, this is from a bike sharing scheme from Washington, DC, from the data is from 2011, 2012. So you can see in our data set, this is a very typical time series data set. And, I guess like pretty much everyone we speak to on our client calls has heard of forecasting. Time series sometimes people have not heard of so much, which is interesting because you say time series forecasting, it's basically the same thing as forecasting. You can't really do forecasting without a time series. But this file basically shows you what a time series is, or time series data. So each row has a timestamp, and you can see each row, or the time difference between each row is an hour here. So we have like 24 hours from January 1st, and then we're through to January 2nd. And then within each hour, we have the CNT column, which refers to the count of registered users who are using the bike sharing service during that hour. And then we have these 5 other columns. So you can see we have some weather data, wind speed, humidity, temperature, a couple of different temperature parameters or variables. And we also have a holiday variable, which says whether it was a public holiday on that day or not. So as you can imagine, the weather variables and the holiday variable could all have a pretty large bearing on the number of registered users within a given hour or on a given day. So as you can probably guess, what we're trying to forecast with this data set is the number of registered users. So we have our historical data, and we want to build a model which lets us input the historical count data, the historical number of registered users using the service over time, and also the weather and holiday information. So that would be both historical and maybe the future information that you're trying to predict as well. So we're trying to predict the count of users, right? But we would know public holidays in the future. Weather, we don't know for certain what the weather is in the future, but we might have some forecast information that we'd be using. And we can, if we don't have that future weather forecast data, we don't have to use that. That can be taken care of automatically by TangentWorks. So you can imagine in some cases you'll have some of this these predictor variables going into the future, and in some cases you won't. You can do forecasts either way. If you have good estimates of the future data, then that can help the accuracy of your forecasts. But it's very common to do forecasts without having future information on your predictor variables. So in machine learning jargon, this column B, what we're trying to predict, is called the target variable. These other columns are called features or predictor variables. So this is the basic data set, and the first thing I can show with TangentWorks is actually using the extension, the Excel plugin that they've built. So you can see I have this built into Excel. It's very easy to install this. You just download a file and tell Excel that you want to import it, and then this thing will become available. So we just have, we can select which target we want to predict, and then select which predictors we want to use. We want to use all of these predictors, features, and let's say we want to forecast 24 hours into the future. So I just do that and click the Make Forecast button, And then you can see it tells us the progress. And within a couple seconds, we'll see we have the forecast. And so this data is now the forecast results are just added to the end of the data set. So you can see, we had data, historical data going up to 10th of August 2011, and now we've made the forecast for the next day, and we have the forecast for the count of registered users there. Okay, so that's the first sort of results we've seen from TangentWorks, and this is using the instant forecasting approach, which Philip was introducing before. So now let's look at another way of using TangentWorks. So for this, we're going to cross over into Qlik. So this is the Qlik integration plugin that the TangentWorks team have built. So we have integrations with Excel, with Qlik, I think also with Alteryx. We're working on other integrations as we speak. So this Qlik integration, we can see the raw data in this table. We can see a time series chart or a line chart showing a number of registered users over time in this data set. And then here we have the forecast results. So you can see here we've done a forecast of length 168 hours. That's actually 1 week. 7 times 24 hours is 168. And you can see in blue we have the actual data, and then in red we have the forecast predictions. So in this case, we're actually forecasting from within the time period where we already have actuals. So that approach is typically called backtesting. You can use that to validate the quality of your model. You'll see that we have these tree map visuals as well. So these are basically telling us which features are contributing the most to the model. So if I expand this, we can see that the count of registered users, this percentage basically means that this is contributing the most to the predictions that the model is making, i.e. the historical count of registered users over time is the most important feature, which makes sense. If you're trying to forecast the number of users for the next week, well, the number of users in the last week or the last month or whatever is going to have a large bearing on your prediction. And then it also shows us that the temperature is important, and then the other features with less importance there. There are actually 2 tree maps. So there's a much more complicated one here. In the first tree map, we saw the sort of importance of the individual features. This tree map is way more complicated, but this actually sort of better represents what TangentWorks is doing under the hood. So what's going on here is that, and what you basically always have to do in time series forecasting, you don't just take the raw input features, you don't just take the raw predictor variables, you have to carry out a number of transforms on them. So for example, the most important transform here is taking a moving average from the target variable count of registered users, and it's also taking a lag of about a bit more than 3 days of like the historical lag of the number of registered users, and sort of combine those two transforms. And then we have various other things. There's like sign transforms. This is also taking values from Thursday here. This is like a cross interaction between the target variable, the number of registered users, and the temperature. So you can see it's making all these different interaction terms, because it could be that as the temperature increases, that changes how much the count of registered users affects the results. So you can see this gets pretty complicated. Now, if you were building the forecast manually, how would you know which input, which of these transforms and which interaction terms between the predictor variables you would have to use? So the answer is that you don't really know that ahead of time, and the usual way to figure that out is that you try a bunch of stuff and kind of see what sticks. And when I say see what sticks, that means you build a model, compute a validation metric for it. So maybe you could look at the average percentage error compared to the actuals if you're doing some backtests. And you do that for one set of transforms, and you try like another bunch of transforms, and you keep doing that until you feel like you're getting good results from your validation metric. So as you can imagine, that's a very time-consuming process. I mean, really, it's the same for all types of machine learning or building all types of statistical model. But time series forecasting is kind of notoriously time consuming, because especially because you have to do these different transforms, like you have to try these different things like moving averages and lags and like sine transforms and so on. So it's a lot of possibilities to consider, and TangentWorks really helps with that. And the way TangentWorks approach that is they have this mathematical approach, which is borrowing from a field of mathematics called information geometry, and it's using that approach to basically find the optimal set of feature transforms. So rather than effectively doing brute force, which is how you would do it if you're doing this manually, it's also how the AutoML approaches that Philip was talking about earlier would handle this. So there are some tools out there which will sort of, called the AutoML tools. They'll basically just throw a bunch of feature transforms at the wall and see which ones stick, which can get good results, but it's pretty time consuming as well, requires a lot of compute power. TangentWorks is a totally different approach. It's using a mathematical algorithm to find the best set of features for the model. And for that reason, as you saw when I was showing the Excel example, you can get results back within a matter of seconds. So that's what kind of really shows, like I can show if I change the forecast length here, then we'll get an updated prediction. And this is not quite as fast as it could be because some aspects of the Qlik integration is still being worked on. I think once we fix those things, this will probably be down to like a second or two, but you can see it's still pretty fast. But it's really the combination of being able to build these models automatically, and the accuracy of those models and the speed at which you can build these models. That's like the real kind of revolution that TangentWorks is bringing. The fact that you can build these automated models within the matter of seconds really opens the door for a lot of possibilities. So you can see here we have an interactive model. I mean, if we were using AutoML for this, we'd literally have to wait, say, like half an hour, an hour, or even longer to get results back. So we can't. It's not really going to be useful for an interactive BI application in that sense. So one great sort of use case for having such fast automated forecasting abilities is these interactive apps that you can build in Qlik or other BI tools. Another sort of kind of big possibility is to run sort of automated forecasting, say on a wide, if you have to forecast for like 1,000 or even more fields in your data warehouse, you can set it up in scale, and you can be doing that as frequently as you want to. If you need to rebuild the models every hour or even every minute, then with enough compute power, you can just set up TangentWorks running in parallel, and you can run huge amounts of forecasts at scale. Another possible use case is around anomaly detection, and I'll be showing this once we get into the Tim Studio web platform. Basically, the idea is once you've built a forecast, you can then also do anomaly detection by comparing the actuals as they come in to what the forecast prediction was. And if those are very different, then beyond a certain threshold, then you've found yourself an anomaly. So you can imagine setting that up on a data warehouse such that any important fields in your data warehouse or any important measures that you've set up for which you want to set up anomaly detection, TangentWorks makes it very easy to automate that process of doing anomaly detection, and then we can send out alerts and so on once anomalies have been detected. Okay, so showing the Excel integration and the Qlik integration. So now I'm going to jump to the Tim Studio web platform itself. We showed the integrations first because we can imagine a lot of customers using those integrations, but now let's see the actual Tim web platform itself. So I'm going to go through a forecasting example first. So this is the data set, the CSV file which I showed in Excel before, the bike sharing data set. So I've already uploaded it, and we can look through the data. So this shows in blue the time series, or the sort of line chart showing our target variable over time. If you remember, CMT is the count of registered users. That's what we're trying to predict here. We can also layer in the other features on the chart. We can also zoom in, zoom out easily. It's a nice, easy to use little view just for checking the data. But at this point, we haven't built a model yet. We just have the data loaded. So let's actually build a model now. So there are different ways to build models. The fastest way of doing it is to use the instant ML feature, which basically is by clicking on this Thunderbolt icon. So let's say we want to forecast like 1 day in the future. I just do that. So with the instant ML approach, you can see we didn't have to set any configuration for our model. It's literally just like a one button sort of thing. You can see the forecast is done now, and we've forecast.
Hey, Daniel,
Yeah.
sorry, this is Philip. I'm wondering if your screen might be frozen. We're still on the workspaces page of the Tangent Work Studio.
Okay, thanks, Philip. Let me just share my screen again.
There we go. Okay.
So you see the forecast page now?
Yep, we can.
Okay, great. So I'm going to do that again. It's so fast that there's no problem doing that again. So as I mentioned, we're going to build our forecast, and we're going to do that using instant ML. So I'm just clicking on this Thunderbolt icon, setting this to forecast 1 day ahead, and I just hit Add Forecast. So you can see there are no configuration parameters for the model required at all. This is completely automated, so it's just a one-button thing. Also, everything you see in the web platform can be done via API. So the forecast is now done. You see that just took a few seconds, and now we have our forecast for the next day, which looks similar sort of pattern to the previous days. You can see that it's quite nice because it's kind of included a lot of the patterns that we see throughout each day. I think what we probably have here is a weekday, because you can see there's a big peak at this point around about rush hour in the morning when people are commuting, so around 8 a.m. And then another big peak towards the end of the day, 5 o'clock, when people are going home from work. So you may be able to guess why these two sort of peaks look different. So these are weekends where we have a big spike around about 1. So people are not commuting at the weekends; they're instead using the bike share to, I don't know, go for a late brunch or whatever they're up to at the weekend. So I think so the model can kind of show these details. Let's try a 7-day forecast and see if that kind of shows those characteristics. So it's saying everything in the web platform that I'm doing with the mouse, you can also do via API. So you can imagine like, for example, the sort of automated forecasting and a data warehouse example I was talking about. You can imagine setting this up to automatically build forecasts, say every hour for your data, and sort of automate that within your data warehouse. So as we can see, we see this nice pattern on the weekdays with the sort of commuter times, and then it's also successfully picked up the patterns of the weekends where we have these spikes around about lunchtime and sort of mid-afternoon, and then we're going back to weekdays here. So it's pretty cool. Like I just clicked a single button basically, and we have like a pretty accurate looking forecast. And under the hood, there's a lot going on. Remember, it's done that automated feature engineering to find the appropriate features. And as Philip was saying earlier, in time series forecasting, there are different types of model you can use, like neural networks or linear regression or tree-based models and so on. But a lot of the time, and it's a general thing with machine learning, the model is only going to be as the data that goes into it. And with time series forecasting, because the transforms that you run on the input variables are very important, taking moving averages and lags and so on, it's often the feature engineering, like those transforms that you do on the input data, that actually has more bearing on the results, on the accuracy of your forecast, than the choice of model. So the choice of model being like neural network or tree model or linear regression, all these kind of fancy sounding algorithms that you hear about if you go on data science blogs. But really it's the feature engineering which is key. And it's a feature engineering area where the TangentWorks team has kind of made this big advance using this new mathematical approach, kind of borrowed from the field of information geometry, to find the appropriate features for a model extremely quickly. Okay, so that was the instant forecast. If we want to have a bit more control over how the model is built, then we can also build a model manually. So we first set up a new model definition. So I already have one in there, so let's call this model 2. So we first choose our data set. We only have one data set, so we'll just choose this. We can decide when we want to forecast. This is, if you're using the API, it would look like this. This is basically saying that we'd be doing a forecast every day at 20 past 8 in the morning. Yeah, and then this is forecasting ahead by 1 day. If we want to forecast ahead by 7 days each time, then we can, well, that would be fun, but we can forecast ahead to 7 days if we want. I'll just see if there is one. We can decide which features we want to use. Also in here, we can determine if we want to use, or if we have, or are likely to have, future variables for these predictors. So for now, we can assume that we have future information for these input variables, because we can assume that we can get weather forecast data to use to help with our predictions, and we also know which public holidays are coming up. We can change the training region, and there was a bunch of sort of advanced features for data scientists who want to get into that much detail. Once we've done that, we just finalize our model building definition, and then we just hit build model, and that will build the model for that model definition. That should just take a few seconds to build. And then once that's done, we can look at the details for that model. And so here, again, we see this tree map. So we can see our predictions in pink. That's the forecast here. So like I can zoom in on that a bit. You can see these are the predictions made on the training data. You can see that the pattern is like very, very close to what we're seeing. It's really modeling a lot of the complexity that we see in the data. These are some weekdays here where we're seeing these peaks that we were looking at before. You can see it's also modeling the weekends effectively. So, and you know, one thing that the tree map shows you is just the complexity of this model. This is not just kind of taking the historical count of registered users and just using that. And you know, it's not just like copying that each week going forward. It's doing all these different transforms on the input variables, making these interaction terms, and you know, all of these go towards making the model sort of fairly complex, but complex in a good way, complex in a way that it can model this complex behavior which changes at weekends and on weekdays and so on. One of the settings you can actually change in the web platform by default, if you're doing these, if you have hourly data, then it will actually, what it's actually doing here is building a different model for each hour. So each hour of the day, there's actually a different model built. So there's a couple of different approaches there. You can do that, or you can actually build a single model, and that will just kind of use the same model for each hour in the day. And many times you might get better results from building separate models for each hour, so that's the default. But if you want like a slightly simpler approach, then you can just build a single model. You can see also the coloring here shows us that like the green values here are interaction terms. Like blue is just one of the targets on its own, or sorry, the target on its own. That's the number of registered users. It's a moving average here. And then, let's see, I don't know if we have any raw predictors. Yeah, so in some cases, some of the models might use just the raw predictor without any interaction terms. Cool, so that's the model building. We can see the forecast on the training data here. If we go to experiments, that also allows us to do some back testing. Let's see, so we can select the range that we want to backtest for. Let's choose like May until August. So this is just going to build a model for that time period that I just selected, and then after that we'll hit validate, and we'll be able to see the predictions and see how well our model is doing. So just to be clear, that the model I built was using sort of whatever I selected, I think from January at some point until the end of the dataset in August, and then we'll do the validation on from say like July 1st until the end of the dataset. So we've built the model from most of the dataset, and then we're just going to make predictions for the last month or so. That's often the way that we do backtesting in practice. Okay. So now we see the results there. Again, pretty closely tracking what we're seeing in the raw data. It also gives us some individual error metrics. So if we want to summarize how well the model is doing in a single number, then we can take this error metric, say the average percentage, that is the mean absolute percentage error. Okay, so that's the forecasting. One last thing I wanted to show in the demo is anomaly detection. So anomaly detection is actually using the same approach under the hood. It's still building a time series forecast model, but the idea is you basically select a threshold. So let's do that. So we'll select our same bike sharing data set, and you can see we have the sensitivity. So I'm going to set the sensitivity to 1%, and that basically means roughly 1% of our data is going to be labeled as anomalous. So we can change that sensitivity depending on how many sort of anomalies we're expecting to see in a sense. And usually you would sort of try varying that until you're getting results that look reasonable. If you set the sensitivity very high, you'll be finding all of the potential errors, but you may be a lot of noise in there as well. If you set it too low, then you may not be sensitive enough to get the number of errors. We can just skip to finalize because we don't need to change the other modeling parameters. So then we just build a model. So like I said, this is just the same model building algorithm under the hood. Then in a second, once that's done, we'll go to the detection page, and then we can actually see anomalies for that model. Okay, this model seems to be taking a bit longer to build. But let's look at one we've already built. So again, we see the count of registered users over time. And then when we sort of overlay the anomalies on this, the red dots show the anomalies that have been detected. So you see, like the anomalies, it's not just looking at high and low values. You can see the red blobs are kind of distributed across the range of number of registered users here. So it's not just looking for very high and very low values. And it's not just looking at the count of registered users. In fact, it's taking the actuals, like the real count of registered users for that hour, and it's also taking the prediction, and then it's looking at the difference between the two. And that's what we see here. This is the difference between the prediction and the actual. And in machine learning terms, we call that the residual. And basically, if the residual as a percentage is above this threshold that we set, remember we set the sensitivity to 1. So this is basically saying that if any prediction is, or if any actual is like 1% away from the actual, then we'll have an anomaly set here. So you can see anything over this pink threshold line is being set as an anomaly. Cool. Great. So that kind of shows how you can do time series forecasting and also anomaly detection in the TIM web platform. We've also shown the Qlik integration and the Excel integration. Like I said, we also have AlterX integration, and we'll certainly be working on more of those as time progresses. But yeah, with that, I think that's the end of the demo. So I guess I can hand back to Philip, and also if there are any questions, then I'm sure we'd be happy to answer them.
Thanks, Daniel. Thank you very much. Let me share my screen here. I'm assuming you can see that, Daniel?
Yeah, I see that.
Excellent. Yeah, and let me just summarize something. TIM and time series forecasting now because of Tim, is incredibly accessible to your average business user. I hope that was evident with the demonstration of the Excel and Qlik integration. But it's also not a toy. It is certainly incredibly powerful and very, very helpful and useful for data scientists, enabling you to really benefit from the technology under the hood there that Daniel kind of talked to us about. We would love for you guys to log on to that URL. We're going to be sending the slide deck, maybe a URL link to the recording, as well as some other information to you as a result of your registration to this. So if you don't copy it down correctly or miss some of these details, we will be forwarding them on to you. And I also encourage you to reach out to Daniel directly as well. His email address and phone number are there, and we'd be delighted to help you with some of your business problems. Next week, in fact, we're going to be in Boston at the Microsoft Azure Data Fest. Tim is integrated with many of the components on the Azure platform, including Data Factory and Microsoft, some of the other Microsoft AI platforms and IoT platforms that Microsoft has to offer. And so we'll be looking forward to seeing you there, and we'll be at the Cloudera booth, and we'll be demonstrating some time series forecasting at an enterprise scale using Tim at that booth. So we hope that we leave you with a message that Tim is available, ready right now. You can access your free trial and start playing around with it right now with your time series forecasts. And if you have some more ambitious goals to try and use time series forecasting to do some of the work at where in some of your use cases, then it's ready to go. I got one question here on whether Tim is available on-prem or as a SaaS offering, and the answer to that question is that it's available as both on-prem as well as a SaaS offering. So depending on how you'd like to deploy Tim, we can certainly accommodate both of those. Daniel, do you have any questions coming from your side there?
Yeah, we have one question. Somebody asked, given this is historical data, are you able to show the actuals of the day you forecasted to see how accurate the results were? So I can share my screen again, actually, and just show that. I mean, maybe the person who asked that question, maybe they've already seen that was possible, because we sort of did cover that in the demo, but I can show that again for sure.
Yes, and the answer, of course, is yes. But it would be good to reinforce that with a view.
So this is the experiments page that I was showing before. So this is where we're doing a back test. So when we did the instant forecast, that just forecasts into the future. But if you want to do back tests, then you can use this experiment feature or build the other sort of manual model building approach. So you can see we've built the model from January up until June or so, and then we're sort of validating for the June data. So when I zoom in on this,
so let me be clear, Daniel. From June onwards, you've got both actual and you've got a forecast, and the forecast for June going forward was built on all the data before June.
Mm-hmm. Yeah, exactly. So when we look at this, we see the actuals in blue, and then the forecast in yellow. It's called an out-of-sample forecast because this is data that was not used to train the model, right? The model was trained with data before June or so in this data set, and then we're forecasting ahead from there.
Excellent. Very good. Very good. Well, we had planned for this webinar to be 45 minutes. We appreciate everybody's time. We thank you so much for attending, and we will be in touch. And this wraps up our webinar. And thank you very much for being such great customers and colleagues and friends. So have a great day. Bye bye.
Thanks everyone. Bye.